Aeronautical decision-making is one of the most critical skill sets a pilot can develop. Unlike stick and rudder skills, decision-making is a mental process, and like any skill, it can be taught, practiced, and improved. Chapter 2 of the FAA Pilot's Handbook walks us through a systematic approach to how pilots consistently identify the best course of action in any situation. Throughout this chapter, we'll explore the core components of sound aeronautical judgment, including risk management, recognizing and correcting hazardous attitudes, applying structured decision models, understanding human factors that affect performance, maintaining situational awareness, and managing automation effectively. Whether you're a student pilot or an experienced aviator, sharpening your decision-making skills is what separates good pilots from great ones. Let's get started. Aeronautical decision-making, or ADM, is defined as a systematic approach to the mental process pilots use to consistently determine the best course of action in response to a given set of circumstances. In simple terms, it represents what a pilot intends to do based on the latest information available at any given moment. Understanding why ADM matters starts with one sobering statistic. Approximately 80% of all aviation accidents are related to human factors. This means the vast majority of accidents are not caused by mechanical failure or weather alone, but by the decisions pilots make. The highest accident rates occur during the most dynamic phases of flight. Landing accounts for 24.1% of accidents, and takeoff accounts for 23.4%. These are the moments when sound decision-making is most critical. ADM gives pilots a structured framework for risk assessment and stress management, and it recognizes that personal attitudes directly influence the quality of the decisions we make in the cockpit. Advisory Circular 6022 serves as the foundational guidance document for ADM training in general aviation, providing background, definitions, and practical tools. Throughout this course, we will build on that foundation to help you develop stronger, more consistent decision-making habits. Aeronautical decision-making operates through two distinct processing modes, and understanding when to apply each one is a critical pilot skill. The analytical model is your deliberate, step-by-step approach. You begin by assessing the situation, move through detection of a problem, carefully evaluate the associated risks, your capabilities, and potential outcomes, generate possible solutions, select the best course of action, and then observe the effect. This process works well when time is on your side, during pre-flight planning, in cruise flight, or any time you have the luxury of thinking things through methodically. The automatic model compresses that loop significantly. Here, the pilot and aircraft are treated as a unified system. You detect, evaluate, determine a likely outcome, and act rapidly. This mode depends heavily on your training and accumulated experience. It's what carries you through emergencies and time-critical scenarios where there simply isn't time for deliberate analysis. The key takeaway is knowing which mode the situation demands. Strong pilots develop the habit of recognizing early when a situation is escalating from analytical territory into automatic response territory. And they build their automatic responses through consistent, quality training, so those reactions are reliable when it counts. Landing and takeoff together account for nearly half of all general aviation accidents, yet these phases represent only a small fraction of total flight time. Think about that for a moment, and pilots spend the vast majority of their flight time in cruise, which makes up roughly 83% of a typical flight, yet cruise accounts for only about 15.7% of accidents. The real risk is concentrated at the beginning and end of the flight. The transition phases, takeoff, climb, approach, and landing, demand the highest level of attention, decision-making, and aircraft control, all while operating at lower altitudes where there is little margin for error. This data should reinforce a critical mindset shift. The fact that you've made it to the pattern or the runway does not mean the hard work is done. In many ways, that's exactly when it begins. As you progress through this course, keep these numbers in mind. Proficiency in traffic pattern operations, stabilized approaches, and proper landing technique isn't just good airmanship. It's directly tied to where the accident statistics tell us pilots are most vulnerable. Aeronautical decision-making has a well-established history spanning more than 25 years of formal recognition within aviation. Researchers and safety experts have long understood that good pilot judgment is not simply a natural talent. It is a teachable skill that directly contributes to safe operations and accident prevention. The foundation for structured decision-making training came from the airline industry, where Crew Resource Management, or CRM, was first developed. CRM programs focused on how pilots interact with human resources, aircraft hardware, and available information to make better decisions under pressure. In 1987, the FAA published 6 pilot decision-making manuals, marking a significant milestone in general aviation training. The research behind these publications was compelling. Pilots who received ADM training made between 10 and 50% fewer judgment errors compared to those who did not. Perhaps the most powerful evidence comes from real-world operational data. One aviation operator, flying an impressive 400,000 hours per year, implemented ADM recurrency training and documented a 54% reduction in their accident rate. That is not a marginal improvement. That is a transformational safety outcome. These results tell us something important. The way a pilot thinks and makes decisions is just as critical as technical flying skill. ADM training works, and the data proves it. Effective aeronautical decision-making isn't a single skill. It's a structured process built from 6 interconnected steps. The first step is identifying hazardous attitudes. Each of us carries personal biases and tendencies that can cloud our judgment in the cockpit, and recognizing them is the foundation of safer flying. From there, Step 2 focuses on behavior modification, learning practical techniques to counter those attitudes before they influence a critical decision. Step 3 addresses stress, which is one of the most underestimated threats to decision quality. Understanding how stress degrades your performance allows you to manage it proactively. Step 4 builds your risk assessment skills, giving you a systematic way to evaluate hazards and prioritize them appropriately. Step 5 reminds you that you are never flying alone in terms of resources. Your instruments, charts, ATC, fellow crew members, and checklists all exist to support your decisions. Finally, Step 6 closes the loop by encouraging you to continuously evaluate your own ADM effectiveness. Good decision-making is not a destination. It's an ongoing discipline that improves with honest self-reflection and practice. Hazardous attitudes are patterns of thinking that can lead pilots into dangerous situations, and recognizing them in yourself is one of the most important safety skills you can develop. The first is anti-authority. This is the pilot who resents being told what to do and views regulations as unnecessary obstacles. The antidote is simple. Follow the rules, because they are usually right. Those rules exist because someone learned a hard lesson before you. Impulsivity is the urge to act immediately without thinking through your options. When you feel pressured to decide fast, slow down, not so fast. Think first. Invulnerability is the false belief that accidents happen to other pilots, not you. This attitude leads to unnecessary risk-taking. Remind yourself, it could happen to me. Macho thinking drives pilots to take risks to prove themselves or impress others, and it affects men and women equally. The antidote is straightforward. Taking chances is foolish. Finally, resignation is the feeling that nothing you do matters, so you disengage and let events unfold. Counter this immediately by reminding yourself, I am not helpless. I can make a difference. Recognition is your first line of defense. When you catch a hazardous thought forming, label it, then deliberately state the antidote. Practice these antidotes until they become automatic, because in a critical moment, that mental habit could save your life. Risk management is not just a checklist item. It is a mindset that should be embedded into every phase of your flight operation. The goal is straightforward. Proactively identify hazards before they become problems, and make sound decisions that reduce or eliminate the risks that come with flight. There are 4 fundamental principles that guide this process. First, accept no unnecessary risk. If a risk does not serve a clear purpose, eliminate it. Second, risk decisions must be made at the appropriate level, and as pilot in command, that responsibility falls on you. No one else in that cockpit, and no one on the ground, can override your authority or relieve you of that accountability. Third, risk is sometimes acceptable when the benefits genuinely outweigh the dangers, but that calculation must be honest and deliberate, not rationalized after the fact. And fourth, risk management must be integrated into your planning at all levels, from pre-flight preparation through execution and landing. Effective risk management is what separates reactive flying from disciplined, professional airmanship. When you build this thinking into your habits early, good decisions become second nature. The risk matrix is one of the most practical tools available for evaluating whether a flight is safe to conduct. It works by cross-referencing two critical factors: how likely a hazard is to occur, and how severe the consequences would be if it did. Looking at the matrix, likelihood is rated across 4 levels: probable, occasional, remote, and improbable. Severity runs from negligible, through marginal and critical, all the way up to catastrophic. Where those two factors intersect gives you your risk level: high, serious, medium, or low. Let's walk through the example on screen. Imagine a pilot who is not instrument rated, flying into conditions that are marginal VFR, with instrument meteorological conditions likely ahead. The probability of encountering a dangerous situation is occasional, and the potential outcome, spatial disorientation, loss of control, or controlled flight into terrain, is catastrophic. That intersection puts this squarely in the high-risk category. High risk means one thing: do not fly until that risk is either mitigated to an acceptable level or eliminated entirely. The matrix doesn't just tell you there's a problem, it tells you how urgently you need to act on it. Use this tool before every flight as part of your personal risk assessment process. Before every flight, a single pilot must take a moment to honestly assess their own fitness to fly. The I Am Safe checklist is one of the most practical tools available for doing exactly that. It walks you through 6 critical personal risk factors, starting with illness. If you're sick, even with something minor, your cognitive and physical performance may already be compromised. Medication comes next. Some over-the-counter drugs can impair judgment just as much as a prescription. Stress is easy to underestimate, but financial, personal, or health-related pressures genuinely reduce your ability to concentrate in the cockpit. Alcohol is straightforward. The FAA requires 8 hours from bottle to throttle, but research shows impairment can persist well beyond 24 hours. Fatigue is particularly dangerous because it's insidious. Your performance degrades before you're even aware it's happening, meaning errors can occur without any internal warning signal. Finally, emotion. If you're upset, grieving, or angry, your decision-making quality is directly affected. The key to this checklist is honesty. There are no right answers to perform for anyone else. If any one of these factors gives you pause, that alone is sufficient reason to delay or cease or cancel the flight. The PAVE checklist is a structured framework pilots use during pre-flight planning to identify and evaluate risk across 4 key categories. The goal is simple. If the risks in any category cannot be managed to an acceptable level, you cancel the flight. The P stands for pilot in command. Before anything else, you assess yourself. Are you current, proficient, and physically and emotionally fit to fly? Use the IMSAFE checklist as your personal health and readiness tool. The A stands for aircraft. Is this the right aircraft for the planned flight? Is it properly equipped with the instruments, lighting, and navigation and communication equipment you need? Do you have adequate fuel, acceptable load, and sufficient runway performance? The V stands for environment. This covers weather, terrain, airport conditions, airspace restrictions, NOTAMs, and night operations. Set personal minimums for each of these elements and hold to them. The E stands for external pressures, and this is the category that deserves your closest attention. Passengers waiting, tight schedules, professional pride, and get their itis are among the most dangerous influences in aviation. External pressure is considered the single most critical risk factor because it can cause a pilot to rationalize away every other concern on this checklist. Recognize these pressures before they compromise your judgment. Let's apply the PAVE checklist to a realistic scenario and see how each category reveals risk. Gail is a private pilot with 300 hours total time, but she hasn't flown in 2 months, making her both inexperienced in cross-country operations and out of practice. Her aircraft is a Cessna 182, a capable airplane, but it lacks GPS and weather avoidance equipment, which significantly limits her situational awareness in deteriorating conditions. The route takes her over mountainous terrain in hazy visual meteorological conditions, and here's the critical detail. Her destination is still reporting IMC at the time of departure. An ARMET Sierra is in effect, warning of instrument conditions in the mountains. And finally, Gail has family waiting for her at the destination, which creates real psychological pressure to launch and push through. When you work through PAVE systematically, the hazards become undeniable. The pilot category flags currency and experience. The aircraft category reveals a lack of equipment for the conditions. The environment category shows active IMC and terrain risk. And the external pressures category identifies the classic get-there-itis trigger. No single one of these factors alone might ground the flight, but together they paint a clear picture. This is exactly why PAVE matters. It helps you see the full risk picture before you ever leave the ground. Once you've recognized a hazard, the next step is to process it and take action. 2 frameworks help you do exactly that: CARE and TEAM. CARE guides you through processing the hazard. Start by asking about consequences. What could actually go wrong here? Then consider your alternatives. Are there other options you haven't fully explored? Next, apply reality, and this one is critical. Be brutally honest with yourself about the risks you're accepting. Finally, think about external factors. What pressures, whether from passengers, schedules, or expectations, might be clouding your judgment. A good rule of thumb: if you catch yourself thinking something will probably be okay, that word "probably" is your signal to stop and do a genuine reality check. Once you've processed the hazard, TEAM helps you act on it. Ask whether you should transfer the decision to someone more qualified. Consider whether you can eliminate the hazard entirely. If not, weigh whether to accept it, meaning the benefits clearly outweigh the costs. And finally, identify ways to mitigate the risk and reduce its impact. Look at how Gail applied this. She hired a CFI for dual instruction, modified her route to stay over valleys, filed a VFR flight plan, used flight following, and established a clear decision point for continuing or diverting. That's CARE and TEAM working together in practice. Crew Resource Management, or CRM, was originally developed for multi-crew flight operations, but the aviation community recognized that single pilots face many of the same cognitive and decision-making challenges. That insight led to the development of Single Pilot Resource Management, or SRM. While a solo pilot doesn't have a co-pilot to share the workload, they still have a wide range of resources available, from onboard avionics and automation to ATC, flight service, weather tools, and checklists. SRM is defined as the art and science of managing all of those resources, both onboard and external, to ensure a successful flight outcome. SRM is not a single skill. It's an umbrella concept that brings together several critical competencies. These include aeronautical decision-making, risk management, task management, automation management, controlled flight into terrain awareness, and situational awareness. Together, these elements form a complete framework for safe single-pilot operations. As we move through this course, we'll explore each of these components in detail because understanding how they work individually and how they interact is essential to becoming a proficient and safe pilot. Understanding the difference between a hazard and a risk is fundamental to sound aeronautical decision-making. A hazard is the condition itself, something that exists in the environment or with the aircraft, whether it's real or perceived. A small nick in a propeller blade is a hazard. It's simply there. Risk, on the other hand, is what the pilot assigns to that hazard. It's the assessment of how likely that condition is to cause harm, and how severe that harm could be. In this case, the risk is prop fracture during engine operation. Here's where it gets critical. 2 pilots can look at the exact same hazard and walk away with completely different risk assessments. Experience, training, physical condition, and other human factors all shape how we perceive danger. Neither pilot is necessarily wrong in their process, but one may be dangerously wrong in their conclusion. This is illustrated perfectly by the King Air accident. That pilot had flown into icing conditions many times before. Each successful flight reinforced a low-risk perception. But past success is not a guarantee of future safety. And on that flight, a critical difference in forecast altitude changed everything. He and his passengers paid the ultimate price for a flawed risk assessment built on complacency and overconfidence. This is why we must evaluate each flight on its own merits, not on what we've gotten away with before. The 5 Ps is a structured self-resource management checklist designed to help pilots pause and assess their situation at key decision points throughout a flight, not just during pre-flight, but at regular intervals while airborne. The first P is the plan. This means continuously updating your mental model of the mission, weather developments, route changes, fuel state, and applicable publications. Plans change, and your awareness needs to keep pace. The second P is the plane. Know the mechanical condition of your aircraft, confirm your database currency, understand what your automation is doing, and know where your backup systems stand. The third P is the pilot, yourself. Run through, I am safe. Honestly assess your fatigue level, currency, proficiency, and emotional state before and during flight. The fourth P is the passengers. Their expectations can create subtle but powerful pressure on your decision-making. Involve them appropriately, communicate openly, and recognize that doing so actually reduces self-induced pressure rather than increasing it. The fifth P is the programming. Know your avionics, GPS, and autopilot, and critically, plan ahead for when and where you will interact with them. Programming during high workload phases like approach or departure is a leading cause of attention capture and task saturation. Used consistently, the 5 Ps keep you ahead of the aircraft and ahead of the situation. The 5 Ps framework is most powerful when you apply it proactively, at structured, scheduled points throughout the flight, rather than waiting until a problem forces you to react. Think of it as a timeline that starts on the ground and follows you all the way to the runway threshold. It begins at pre-flight, before you ever leave the ground. This is the easiest point to make a no-go decision. There's no pressure, no fuel burned, no passengers anxious to arrive. Next comes the pre-takeoff review, a final check before committing to the flight. Once airborne, you reassess at the midpoint or on an hourly basis during cruise. This is where diverting, if needed, is still a practical, low-stress option. You have fuel, time, and altitude on your side to make an unhurried decision. Pre-descent is your next checkpoint, a deliberate assessment before you begin committing to a destination. And finally, the review on final approach. This is the hardest point to change course. You're low, slow, task-saturated, and mentally committed to landing. Decisions made here are made under pressure. The lesson is straightforward. The earlier in this sequence you identify a problem, the more options you have and the safer your decision will be. The 3P model gives pilots a structured, repeatable framework for managing risk throughout every phase of flight. It stands for perceive, process, and perform, and it works as a continuous loop rather than a one-time checklist. In the perceive phase, you use the PAVE checklist to identify potential hazards. PAVE stands for pilot, aircraft, environment, and external pressures. The key question here is simple. What could hurt me, my passengers, or my aircraft? Once you've identified those hazards, you move into the process phase. Here, the CARE checklist helps you evaluate whether a hazard represents a real risk. You're examining the consequences, exploring alternatives, checking your perception against reality, and considering external factors that might influence your decision. The third phase, perform, is where you take action using the team checklist. You choose to transfer, eliminate, accept, or mitigate each risk. Critically, after you act, you evaluate the outcome and feed that information back into the loop. What makes the 3P model especially practical is its flexibility. You can apply it strategically during complex mission planning, deliberately during your pre-flight preparation, or in a time-critical mode when situations develop quickly in the air. Regardless of when you use it, the goal is the same: structured thinking that keeps risk at an acceptable level. The DECIDE model is a structured decision-making framework designed to help pilots work through problems systematically, especially under pressure. Let's walk through each step. First, detect. Recognize that something has changed or that an expected change has not occurred. This awareness is your starting point. Second, estimate. Assess how urgent it is to respond. Be careful to avoid overreacting or becoming fixated on a single problem. Third, choose. Determine what a successful outcome looks like for the flight. Having a clear goal guides your next steps. Fourth, identify. Think through the actions available to you that could effectively address the situation. Fifth, do. Take action by selecting and executing the most appropriate solution. Finally, evaluate. Assess whether your action is producing the desired result. If it isn't, cycle back through the model and try again. The DECIDE model turns what could be a chaotic situation into a manageable, logical process. Practicing this framework builds the mental discipline needed to make sound decisions when it matters most. Let's look at a real-world case study that brings the DECIDE model to life in a critical moment. During a multi-engine check ride in a Piper Apache, the ATP examiner simulated a right engine failure. The aircraft yawed right, a clear directional cue. But under pressure, the student feathered the left engine. The wrong one. The aircraft was substantially damaged as a result. So how does this happen? The student wasn't careless. They were trained. But their training had emphasized left engine out scenarios far more frequently. And in that high-pressure moment, habit and assumption overrode accurate analysis of the actual situation in front of them. This gives us two critical lessons. First, acting without forethought can be just as dangerous as failing to act at all. There was time to correctly identify the failed engine. That time simply wasn't used. Second, decisions made under pressure are vulnerable. They may be based on incomplete information, limited experience, or deeply ingrained patterns that don't match the current situation. The DECIDE model exists precisely to slow that process down, to give you a structured framework so that pressure doesn't hijack your judgment. Identify the problem accurately before you act. That single step could have changed the outcome entirely in this case. In high-stakes, time-critical situations, there simply isn't time to work through a structured, analytical model step by step. This is where naturalistic decision-making comes in. Experts operating under pressure don't evaluate every possible option. Instead, they rapidly assess whether a situation matches a pattern they've seen before, then mentally simulate one or two courses of action to see if they'll work. They take the first workable solution they identify, not necessarily the optimal one, but one that's good enough to move forward effectively. This ability is deeply rooted in training and experience. It's the same mental process used by experienced firefighters reading a burning building, chess masters anticipating moves, and seasoned pilots managing unexpected emergencies. Pattern recognition allows experts to act quickly and confidently where others might hesitate. Importantly, naturalistic decision-making is not a shortcut that replaces proper training or analytical thinking. It develops through experience and improves with deliberate practice. In most real-world situations, you'll use it in combination with analytical tools, drawing on both as the situation demands. Understanding this model helps you appreciate why building deep expertise matters, and why experienced judgment under pressure is something that must be developed over time, not assumed. Even experienced pilots are not immune to the behavioral traps that have contributed to countless aviation accidents. Recognizing these tendencies in yourself is the first step toward eliminating them. Peer pressure leads pilots to make decisions based on what others expect rather than what the situation demands. Never let someone else's agenda override your judgment. Get-there-itis creates a dangerous tunnel vision, where the desire to complete a flight overrides rational assessment of conditions or alternatives. Duck-under syndrome tempts pilots to descend below published minimums, falsely assuming those numbers contain extra buffer. They do not. Scud running places you in deteriorating conditions at low altitudes with shrinking options and reaction time. Getting behind the aircraft means you are no longer flying proactively. The airplane is ahead of you, and surprises follow. Finally, flying outside the envelope reflects overconfidence in either the aircraft's performance or your own proficiency. All of these traps share a common thread. They involve allowing emotion, habit, or ego to replace disciplined, objective decision-making. Awareness is your defense. Human factors is one of the most critical areas of study in aviation safety. Research consistently shows that human factors directly cause or contribute to more than 70% of aircraft accidents. That's a significant statistic, and it underscores why understanding this subject is essential, not just for pilots, but for aviation maintenance technicians and air traffic controllers as well. So what exactly does human factors science cover? It's a broad multidisciplinary field that draws from psychology, engineering, industrial design, statistics, operations research, and even anthropology. At its core, human factors is about understanding human capabilities and limitations, and then using that knowledge to design systems, procedures, and environments that support safe and effective performance. It's important to recognize that human factors goes well beyond concepts like crew resource management or maintenance resource management. While CRM and MRM are valuable applications of human factors principles, they represent just a portion of what this science encompasses. A thorough understanding of human factors gives aviation professionals the foundation to identify risks before they become accidents and to contribute meaningfully to a culture of safety. FAA research involving more than 4,000 pilots revealed a consistent pattern among those involved in accidents. By comparing pilots with clean records against those with accident histories, researchers identified 5 behavioral traits that significantly increase risk in the cockpit. The first is a disdain for rules. Interestingly, this doesn't stay in the cockpit. There is a strong correlation between aviation violations and driving safety violations, suggesting it reflects a broader attitude toward authority and regulation. The second is a thrill-seeking personality. Accident-prone pilots frequently prioritize excitement over sound judgment, which can lead to unnecessary risk-taking. Third is impulsive decision-making. Rather than working through information systematically, these pilots rush both their information gathering and their action selection, skipping the discipline that safe flying demands. The fourth trait is a disregard for outside information. These pilots underutilize the resources available to them: co-pilots, air traffic control, flight instructors, and flight service personnel, all of which exist to support better decisions. What separates safe, successful pilots is the ability to concentrate, manage workload effectively, and monitor multiple tasks simultaneously with both accuracy and focus. Recognizing these accident-prone patterns in yourself or others is a critical step toward building a safer, more professional mindset in the flight environment. Stress is a normal part of flying, and a certain amount of it actually works in your favor. It keeps you alert, focused, and engaged. The problem arises when stress accumulates beyond your ability to cope with it. Think of it like a performance curve. As stress increases, your performance initially improves, but once it exceeds your coping threshold, it drops off rapidly. That's the danger zone for pilots. Stress generally falls into 2 categories. Acute stress is immediate and situational. It comes on suddenly and is tied to a specific event. Chronic stress builds over time and is often the more dangerous of the two, because it erodes your capacity before you even realize it. Stressors themselves come from 3 directions. Environmental stressors include things like temperature extremes, noise, vibration, and hypoxia. Physiological stressors include fatigue, illness, poor sleep, and missed meals. Psychological stressors, often the most overlooked, include personal problems, financial pressure, and high mental workload in the cockpit. The most important technique for managing stress in flight is straightforward. Stop, think, and analyze before jumping to conclusions. In most situations, you have more time than you think. Rushing to a decision under stress often leads to errors that a moment of deliberate thinking could have prevented. Discipline yourself to pause, assess, and then act. Effective resource management is a cornerstone of safe flight operations, and understanding both your internal and external resources ensures you're never truly operating alone, even as a solo pilot. Starting with internal resources, your passengers can be genuinely valuable. They can help scan for traffic, read checklists aloud, or confirm that the landing gear is down. Simple tasks like these can reduce your workload during critical phases of flight. Verbal briefings are another powerful internal tool. When you speak through a decision out loud, you reinforce your own reasoning and are more likely to catch errors. Pairing that with a physical touch confirmation, actually touching a switch while verbally confirming it, has been shown to significantly improve accuracy and reduce missed steps. Your checklists and pilot's operating handbook are also internal resources. The POH is required to be on board and is your primary reference for both normal operations and malfunction resolution. On the external side, air traffic control is one of your most important assets. ATC can provide traffic advisories, radar vectors, and direct emergency assistance when you need it most. Flight service stations offer pre-flight weather briefings, NOTAMs, and can coordinate search and rescue if necessary. And FlightWatch gives you real-time en route weather updates while airborne. Using all available resources, internal and external, is the mark of a disciplined and professional pilot. Situational awareness is one of the most critical skills a pilot can develop. It means having an accurate perception and understanding of everything affecting the safety of your flight, before, during, and after you're in the air. A strong mental picture comes from actively monitoring radio communications, staying ahead of weather changes, and maintaining awareness of other traffic and ATC instructions. The biggest threats to situational awareness are fatigue, stress, work overload, and distraction. When any of these take hold, you risk fixating on a single item while everything else goes unnoticed. A dangerous place to be in a dynamic flight environment. That's where workload management comes in. The goal is to plan, prioritize, and sequence your tasks so that you're never caught off guard. Use low workload phases of flight to prepare for the busy ones. Set your frequencies ahead of time, review your charts before you need them, and complete checklists before entering congested airspace. If you ever feel overloaded, remember 4 words: stop, think, slow down, prioritize. Task saturation causes pilots to make decisions based on incomplete information, and that's when mistakes happen. Managing your workload proactively keeps you in control of the aircraft and the situation, rather than the situation controlling you. Automation in the flight deck brings tremendous advantages, particularly in single-pilot operations. Moving maps, traffic and terrain awareness systems, weather data link, and electronic databases have replaced stacks of paper charts and handbooks, giving pilots more information than ever before. The autopilot frees mental bandwidth so you can monitor systems, communicate, and plan ahead rather than hand-flying every moment of the flight. But with those benefits comes a serious risk: over-reliance. When pilots depend too heavily on automation, basic stick and rudder skills quietly erode. Instead of flying the aircraft, pilots find themselves heads down, troubleshooting the flight management system while the aircraft takes care of itself. That mindset is dangerous. It's sometimes called being the passenger in command. The 1999 Columbia accident is a sobering example. The crew entered a waypoint just 1 degree off. 1 degree. That small error went undetected as they flew 60 nautical miles off course directly into the Andes. They had every modern tool available to them, and they still crashed because they stopped monitoring what the automation was actually doing. The lesson here is this: automation is a tool to support your decision-making, not replace it. You are always the pilot in command. Trust, but verify everything the system tells you and never allow the technology to fly you. Managing aircraft automation in advanced avionics. Aircraft comes down to 3 interconnected skill areas that every pilot must develop and maintain. The first is information management. Modern glass cockpit systems present an enormous amount of data, and your job is to control that flow rather than be overwhelmed by it. Understand your avionics at a conceptual level and develop the habit of stopping, looking, and reading before making any input. Always double-check your programming before departure. An error entered on the ground is far easier to catch than one discovered in flight. The second skill is automation management. you must know which autopilot modes are engaged and which are armed at all times. Understand how those modes interact with your other systems. And critically, make a point of occasionally disconnecting the autopilot and hand-flying the aircraft to keep your manual flying skills sharp. The third skill is risk management, and this may be the most important. Electronic flight displays do not replace fundamental aeronautical knowledge. Research consistently shows that humans are poor monitors of automated systems, and the more reliable the automation, the worse our monitoring performance tends to become. Complacency is a real and serious hazard. Sound aeronautical decision-making is still your responsibility as pilot in command, and sometimes the best decision you can make is to say no to a flight. Chapter 2 has covered a lot of ground, so let's bring it all together. Aeronautical decision-making is not guesswork. It is a disciplined, learnable skill, and the data backs that up. When pilots apply structured ADM principles, accident rates drop by as much as 54%. That is not a small number when you consider that roughly 80% of aviation accidents trace back to human factors. The 5 hazardous attitudes, anti-authority, impulsivity, invulnerability, macho, and resignation, are not personality flaws. They are predictable traps. Know the antidotes cold, because in a high-pressure moment, you need them instantly. The checklists, IMSAFE, PAVE, CARE, TEAM, and the 5 Ps, are your structured decision-making framework. Use them every flight, not just when things feel complicated, and above all, manage external pressure. It is the single risk factor most capable of overriding everything else you know. Build your personal SOPs now before the pressure arrives. Finally, respect automation without becoming dependent on it. Advanced avionics are tools. You are still the pilot in command, and that requires active engagement, not passive monitoring. Every concept in this chapter serves one goal. Every flight ends safely through informed, disciplined decision-making. Take these tools seriously and apply them consistently.